To begin, shuffle and then select 20 random cards. The cards represent customers, and the numbers on the cards represent the time, in minutes, it takes for that particular customer to be serviced at the checkout. Count the Jack, Queen and King as 11, 12 and 13 respectively. For the first model, a simple stacked system, you will have 4 checkouts. Deal the 20 cards as shown. Data will be collected in a table similar to the one that you can see to the left. Record the numbers in each of the aisles on the data table as shown. In this case, 3, 7, 2 and 12. Note that the customer with the lowest is the 2 in aisle number 3. That customer will require 2 minutes to be serviced. This customer will be moved to the exit, and 2 minutes will be recorded on the data table and on the clock face. This is represented by drawing a line through the 2 in the aisle number 3 of the data table. Since 2 minutes have also passed for the other 3 customers at the checkout, subtract 2 from each and record the result in the row below. They will now read 1, 5, empty cell in aisle 3, and 10. Now place the next customer in line in aisle 3 at the checkout, in this case, a 5. From this point on, you need to consult the data table to see which customer will be the next to finish the checkout process. Here we find that the 3 in aisle number 1 has just 1 minute remaining. In the next row, add 1 minute to the elapsed time, which is now 3 minutes. Move the customer in aisle number 1 to the exit and indicate this in the data table by crossing out the 1 in aisle number 1. Add a minute to the clock as well, indicating the 3 minutes of elapsed time. Subtract 1 minute from the customers at the checkout in aisles number 2, number 3 and number 4, which now should read empty cell in number 1, 4, 4 and 9. Finally, place the next customer in line in aisle number 1 at the checkout, in this case, a 6. Looking at the data table, you can see that in 4 minutes, both the 7 in aisle number 2 and the 5 in aisle number 3 will have completed the checkout process. Add 4 minutes in the time column and cross out both of those customers. Change the clock and move both customers to the exit. Subtracting 4 minutes from the customers already at the checkout leaves a 2 in aisle number 1, empty cells in aisle number 2 and number 3, and a 5 in aisle number 4. Move the next 2 customers, in this case a 4 and a 7, in aisles number 2 and number 3 to the checkout. Looking at the game board, note that there are now a different number of people waiting at the checkouts. 3 each in aisles number 1 and number 2, only 2 in aisles number 3, and still 4 in aisle number 4. This is because the first person in aisle number 4, a queen, requires 12 minutes to be checked out. Hopefully you are not in aisle number 4 behind the queen, because her line is certainly moving the slowest. Continue the simulation and data recording until all customers have been moved through the checkouts. Note that some of the aisles will run out of customers before others. For this model, all customers should remain in their original aisles. Note the total time for all customers to complete checking out.